per day. Right now the U.S. uses about 19 million barrels per day. About 9.5 billion are imports, so we get about 49% of our imports. But these are the major disruptions, and they're not just what happens in the Middle East. It's also what happens in the environment. We have hurricanes. So what does this do to the price of oil? That's the interesting thing. So if you look at the major disruptions and the impact on crude prices, you got the oil embargo. Wow, in 1973, so that started a lot of actions by the Carter administration. You get the Iran war, you get more. Iraq invades Kuwait, you see almost doubling of price. OPEC cuts quotas, you see things going down. You got the 9/11 attacks, it goes back up. You get hurricanes, you see fluctuations. Nigeria cuts off oil. You have economic recession. You have rising demand but lower capacity. Weak dollar, and since actually the price of oil is tied to the dollar, anytime the dollar gets weak, the prices have a tendency to go up, or the dollar gets weaker.
Those are not constant dollars.
Those are constant dollars in 2008 dollars. But a lot of people forget that our energy use is actually just not transportation. Transportation is only 28% of it. There's a huge amount that's used commercial buildings, residential buildings, and industry. And as our previous speaker talked about, there's a lot to be gained by focusing in on improving the efficiency of these buildings. If you look at what's happened since the 1970s, how conservation and energy efficiency has impacted. If we stayed on the same slope that we had prior to the oil embargo, we would actually have been looking at 70 quads of electricity. So it would have been about 1.7 trillion as compared to $1 trillion for the cost of energy consumption. So the oil shocks of the 1970s did drive us to be more efficient in our energy use. So what are some of the factors that affect our energy policy? National and international crises, economic factors, competitiveness and recessions, environmental factors, climate change comes to the forefront, but also Clean Air Act. That's a very important thing. And then sustainability, is when the prices aren't so volatile, we actually do concern ourselves with sustainability and think about the next generation. And innovation is seen as a tool to address all these factors. So that's why R&D support usually gets a lot of broad bipartisan support. If you look at how we do energy policy, I call them decadal bills, because it usually takes about 10 years before you get a truly comprehensive energy bill out of our Congress. And so 2005 is the last time we had a total comprehensive bill. And it covers everything from production, distribution, and consumption. So you get regulatory reform, you get tax incentives and credits, loan guarantees, renewable fuel standards, domestic production, and then research and development. And this bill was really focused on the mid and long term and not necessarily the near term. This was back in 2005. It took us a number of years to develop this bill. So if you go back and look and see what it had some demand side policies. This includes your Energy Star programs, your appliance standards, your lighting standards, and cafe standards. These regulatory policies are sort of to reduce demand. Then you have federal actions that come in place, clean energy purchase requirements from the federal government, energy efficient building requirements, and then the Federal Energy Management Program. The federal government is the biggest user of energy. The Department of Defense is the largest single customer for electricity consumption in the country. And so they actually put in a lot of requirements on the purchase agreements that they buy greener power or they buy more efficient power. Then we have tax policies. Federal excise taxes on gasoline. Gas here is so much cheaper than it is in Europe because we have much lower excise taxes. There's energy efficiency tax credits. That was put in the law in 2005. And then in the past, they used to always look at the windfall profit taxes on oil. That's actually one way to curtail domestic production, is to put a windfall profit tax. On the technology push side of things, you'll see tax incentive as well, the renewable energy production tax credit. Ethanol subsidies, there's a whole fuel versus food debate that continues to go on. But if you're from the Midwest, you're for these ethanol subsidies. If you're from anywhere else, you're not, because, it's very difficult to pipe ethanol. Matter of fact, we can't. That's why it's very localized in its support. Clean energy renewable bonds. A lot of The bills contain opportunities for municipalities to get bonds to use clean energy and renewable projects. Loan and loan guarantees, the renewable energy loan guarantees. This was interesting. There's a big difference between the ones for renewable and the ones for nuclear. The government subsidized the credit subsidies for the renewables, which means you as taxpayers pay for those. For nuclear, the industry pays for it. So there's a big difference. And these credit subsidies are calculated based on the probability of default of the entity that's getting the loan. And so I'm sure many of you may have heard of Solyndra, the solar plant that got subsidized, $500 million, and now they're going bankrupt. Well, had that been a nuclear plant, the nuclear plant would have actually paid for that credit subsidies, that $500 million, whereas the solar actually got paid for through the American Recovery and Reinvestment Act. So there's a big difference. There's, oil and gas production tax credits are in to support domestic energy supply, and then federally sponsored research and development. Now, cost is really what drives a lot of this. And so if you really look at what this study was done in 2007, look at the levelized cost of electricity for new base load. And, so you have biopower, geothermal. Nuclear has a wide range because it depends on what part of the country you're building it in and also what type of reactor you're building. Natural gas combined cycle, and these costs are really driven a lot by the fuel costs. So if the fuel costs go down, this bar is going to slide to the left. If you have to have carbon capture and sequestration, you can see what it does to natural gas. And you have that issue for coal as well. So if you put coal out here, I think this number should be quite a bit higher for coal because there's a huge energy penalty on coal when you actually go to sequestration. You look at wind, offshore and onshore, great variability on what the cost. And the thing is, a lot of times they don't touch on is there's the nameplate capacity of a wind plant, but then there's actually how long it's running, and then how long is it running when it's useful. And they don't really factor in energy storage significantly on that. And then solar PV and concentrated solar power. So really what we need to meet our energy assurance goals are some essential technologies. I think nuclear is essential, carbon capture and storage if really we're going to address concerns with climate change. Wind, solar, these really depend heavily on energy storage. If we can develop energy storage systems, then wind and solar become very viable options for certain regions of the country, not for all. Biomass, electric drive vehicles, advanced liquid fuels, potentially from fossil resources as well. What's very interesting about electric drive vehicles, if many of you may remember back in 2003 and 2004, there was a huge push toward the hydrogen fuel cells. Actually, the Democrats and Republicans both were trying to one-up each other on who was going to come up with the biggest hydrogen future program. And so where are fuel cells at now? Well, there's still systems costs and issues that need to be addressed for fuel cells, and they've sort of been pushed out of the way by electric drive vehicles, and then probably next will be natural gas vehicles. Major improvements in energy efficiency, transportation, buildings, industry, and electricity generation and transmission. These are sort of the essential technologies, and we will still need major advances in basic R&D to ensure success. Okay, well, that was my last slide anyway, and it's not going to that. Okay. Well, thank you for your time.